Namaste, welcome to Pythagoras Academy. This is Vikram Dachepally. This video is dedicated to this model called block on block model. This is really interesting and also important for competitive exams like JEE and NEET. Consider a situation where a 1 kg block is placed on a 3 kg block and there is some friction between them and the coefficient of friction is given to be 0.4. 3 kg block is placed on a smooth horizontal floor. There is no friction offered by the floor. An external force of 12 Newton is applied on 1 kg specifically. Now we are supposed to find the acceleration of the blocks and the friction acting between the blocks. Looking at the situation, the first conclusion that we can make is both the blocks will move. Definitely they are going to move because the floor is smooth. There is no friction offered by the floor. If you consider 1 kg plus 3 kg together as system, there is net force in the rightward direction. So the blocks would definitely move because there is no resistance offered by the ground. Had there been some resistance or friction offered by the floor, there would have been a case where 3 kg block is at rest and 1 kg block is at rest with respect to 3 kg. If the friction is sufficient, the entire system is at rest. This would have been possible had there been some friction offered by the ground, but we can rule that out because the floor is smooth. The second conclusion that we are supposed to make is if 1 kg and 3 kg blocks move together with common acceleration, or they slip on each other moving with different accelerations. So how do we do that is first by checking the required value of static friction to keep the relative slipping 0 between 1 kg and 3 kg. If static friction is sufficient to prevent slipping between 1 kg and 3 kg, then both 1 kg and 3 kg blocks move together with common acceleration. If static friction is not sufficient, there is kinetic friction, there is relative slipping, so 1 kg and 3 kg move with different accelerations. Let us first draw the free body diagram. Assuming that both the blocks are moving together so that we can find the required value of static friction for this to happen. For this to happen, for 1 kg and 3 kg blocks to move together, there must be static friction. So with respect to 3 kg block, if you observe the free body diagram of 1 kg, with respect to the 3 kg block, 1 kg block is tending to move forward because of the applied force. To prevent slipping, 3 kg offers friction on 1 kg in the leftward direction. That is how we decide the direction of friction, static friction precisely. As a reaction, 1 kg block is applying friction on 3 kg block in the forward direction. If you observe the free body diagram of 3 kg, the only force in the rightward direction is friction. It is friction which is taking 3 kg along with 1 kg. Because friction wants to keep the relative slipping 0, so friction is trying to take 1 kg and 3 kg together. So solving the equations that we get by applying Newton's laws. So from the first free body diagram, 12 minus Fs, that is 1 into A, and the second free body diagram, Fs is equal to 3 into A. So solving which we get the common acceleration is 3 meter per second square. And you can avoid a few steps for finding this acceleration of 3 meter per second square by simply considering 1 kg and 3 kg as a single system, because if both of them move with common acceleration, you can consider 1 kg plus 3 kg, 4 kg as a single system. Net force is 12 Newton, friction is internal force, so we don't have to bother about that. So 12 is equal to 4 into A. This equation of 12 is equal to 4 into A, we can arrive just by a simple logic of considering 1 plus 3 as a single system. That you can do when you are actually doing this question in the exam to save some time. Because this is for analysis, I am drawing separate free body diagram and writing separate equations and getting this. Anyhow, from the second equation, I can find the static friction required for this to happen. So 3 into A, 3 into 3, that is 9 Newton. If friction can adjust its value to 9 Newton, then well and good. static friction is sufficient to prevent slipping, we can conclude that both the blocks move together with common acceleration of 3 meters per second square. Let us find the maximum value of static friction, which is mu into n. That is 0.4 into n. N normal force between 1 kg and 3 kg block is 10 Newton. That is weight of 1 kg block. So 0.4 into 10, which is 4 Newton. Friction required is 9 Newton, whereas the maximum value of friction that can be adjusted is only 4 Newton. The maximum possibility is only 4 Newton, but the required is 9 Newton. So we can conclude that static friction fails and the kinetic friction acts between the blocks. There is slipping between the blocks. They move with different accelerations, A1 and A2. This is the conclusion. Let us redo the problem by taking the kinetic friction. So I am drawing the free body diagram again. Now the friction is kinetic. It is not a self-adjustable force or a variable force. It has got a fixed value of mu into n. So kinetic friction is mu into n or mu k into n, which is 0.4 into 10. In this question, simply mu is given, which means that coefficient of static friction is equal to coefficient of kinetic friction, that is equal to 0.4. So that's the reason kinetic friction is also equal to 4 Newton here. Now we know the value of friction, we know the applied force. The difference between the previous analysis and this is we have taken kinetic friction into consideration by concluding that it is kinetic friction. There is slipping. Both the blocks move with different accelerations. Now let us apply Newton's laws to solve. So from the free body diagram of 1 kg, I'll get 12 minus 4. Fk is 4, that is A1. So acceleration of 1 kg block is 8 meters per second square. Whereas acceleration of 3 kg block, the only force acting on it is kinetic friction. 4 is equal to 3 into A2. So acceleration of 3 kg block is 4 by 3 meters per second square. This is the final conclusion of this problem. Friction is kinetic, whose value is fixed, that is 4 Newton. And A1 and A2, 8 meters per second square and 4 by 3 meters per second square. Let us, for a better understanding, let us consider a case where the force F is applied on 3 kg in the same situation. So if the 12 Newton force is applied on 3 kg, let us do the same kind of analysis. I'm drawing the free body diagram of 1 kg and 3 kg. Now look at the free body diagram of 1 kg and 3 kg. With respect to 1 kg, 3 kg is tending to slip. With respect to 1 kg, 3 kg block is tending to slip forward because a force of 12 Newton is applied on 3 kg. So 1 kg block applies friction on 3 kg in the backward direction. So you look at the free body diagram of 3 kg, static friction is acting in the backward direction. So as a reaction, static friction acts in the forward direction on 1 kg block. If static friction is sufficient, both of them will move together. It is static friction which is taking 1 kg along with 3 kg in order to prevent relative slipping between them. Now getting the equations and solving, Fs is equal to 1 into A from the first free body diagram and 12 minus Fs is equal to 3 into A from the second. So 12 is equal to 4 into A. So acceleration is 3 meters per second square. This will not change. After all, the net force on the 3 kg plus 1 kg system is 12 newtons. So 12 Newton is equal to 4 into A. 12 is equal to 4 into A. Acceleration is 3 meters per second square. So from the equation 1, static friction required for this to happen is 3 Newton in this case. Static friction is required, which is the static friction required is 3 Newton to prevent relative slipping. And the maximum value of static friction, Fs max, is mu n. So which is mu s into n actually. The coefficient of static friction is also 0.4. So 0.4 into 10, which is 4 Newton. Required is 3 Newton, maximum is 4 Newton, well and good. So static friction is sufficient to prevent slipping. I can conclude that static friction is sufficient. I can stop the problem here. The conclusion is the friction acting between the blocks is 3 Newton. Friction has adjusted its value to 3 Newton, which is static friction. And acceleration of 1 kg block and 3 kg block is common, which is 3 meters per second. If you have any questions or queries or suggestions, you can always use the comment section to interact with me. I'll be more than happy to respond and receive your feedback. This is Vikram Dachepally signing off. Namaste.